Good afternoon, sir. This is Isma. This is group 2, and the participants are with Conrad, Nasa Jovia, and Grace by myself. So we're going to talk about data pre-processing. So data pre-processing, this is what we are going to look about. We are going to talk about an overview of data pre-processing, which includes data quality, measure tax, and data processing, data cleaning, data integrity, data reduction, data transformation, and then here data quality. Why process the data? Reasons for processing data include the following: measures for data control. Then we have data cleaning, data introduction. These are the major tasks in data preprocessing. Data cleaning is the filling in missing values, smooth noisy data, among others. Data integration is integration of multiple databases. Data reduction includes dimensional reduction, numericity reduction, data compression. Then we have data transformation and data criticization, which includes normalization, concept hierarchy generation. Then what is data? Data is in the real world is data. Here we are going to talk about data cleaning. Data in the real world is data, also potentially incorrect data, instrument faulty, human or computer error transmission. We have incomplete. Sometimes data is incomplete, where it lacks attribute values. Sometimes data is noisy, containing noise, errors, or outliers. Sometimes data is inconsistent, containing discrepancies in codes of names. Sometimes data is intentional. It disguise missing data. Incomplete or missing data. Data is not always available. That missing data may be due to equipment malfunction, inconsistent with other recorded data. Certain data may not be considered important at time of entry. Don't register history or changes of data. Missing data may need to be inferred. How to handle missing data? Ignore the tamper, usually done when class label is missing. Fill in the missing value manually. Fill in it automatically with a global constant and attribute mean. The attribute mean for all samples belong in the same class. Then you have noisy data. What is noise? Noise is the random error variance in a measured variable. Incorrect attribute values may be due to faulty data collection instruments, data entry problems, data transmission problems, technology limitation, and then inconsistency. Other data problems which require data cleaning, we have duplicate records, incomplete data, inconsistent data. How to handle noisy data still, we have binning. First, sort data and partition into bins. Then we have regression, smooth by fitting the data into regression functions. Then we have clustering, detect and remove outliers. Then we have combined computer and human inspection, detect suspicious values and check by human. Data cleaning as a process. Data discrepancy detection, we use the metadata, check field overloading, check uniqueness rule, use commercial tools. Then we have data migration and integration. Here we have data migration tools which allow transformations to be specific. ETL, which is the extraction transformation loading, which allows users to specify transformations through a graphical user interface. Then we have introduction of two processes, interactive and interactive export as well. Still on data preprocessing, we're going to talk about data integration. Data integration combines data from multiple sources into a coherent store. Schema integration integrate metadata from different sources. Entity integration problem, identify real-world entities from multiple data sources. Then we have handling data in data integration. Data and data occur through integration of multiple databases. Redundant data attributes may be able to be detected by correlation analysis and covariance analysis. Careful integration of data from multiple sources may help reduce, avoid redundancies and inconsistencies. Then we have here we have the correlation analysis on the data. That's the formula. Then the larger the X2, the more likely the variables are related. Then correlation does not imply causality. As you can see the formulas, those are the formulas for data chi-square correlation, an example of chi-square correlation. Then we have numeric data, that's an example how it is done. Then we have visual evaluating correlation, that's a scatter plot showing the similarity form from -1 to 1. As you can see from top, we have -1, then from the bottom, we have 1. It comes from 1, -1 up to 1, as you see. We have correlation viewed as linear relationships. Correlation measures the linear relationship between objects. Complete correlation which analyze data objectives A and B and then check their dot product, as you can see. Then we have covariance, numeric data. Covariance is similar to correlation. As you can see, correlation coefficient R squared B, then we have where n is the number of tuples, A and B are respective mean or expected values of A and B. Then we have positive variance. Then here it happens when convariance is greater than 0. Negative covariance is where convariance is less than 0. Then we have independence. Independence is where convariance is equal to 0, but the converse is not true. So these are the examples of covariance. So next up is data reduction, and maybe my colleague we are gonna start from there. Thank you very much. That was very small.
Data reduction. So we are looking at data prepocessing. So when we look at data reduction, to obtain a reduced representation of data, set that it's much smaller in volume, yet produces the same amount of information from analytical results. Why? Just because we are going to hold a very big databases that we hold big data. So it's better to reduce data to very smaller sizes. Data reductions strategies, we have dimensionality reduction, numeric reduction, and data compression. So what do we mean by dimensionality reduction? Remove unimportant attributes. Remember when we talked about dimension modeling, we talked about attributes in the fact table. So here we're going to remove them. And then in the next one, we have data compression. So here when we talk about dimensional reduction, when dimensionality increases, data becomes increasing sparse, distance between points, and which is crucial to clustering. Outlier analysis becomes less meaningful. A possible combination of the subspace will go exponentially. So to avoid the cost of its dimensionality, help to reduce irrelevant features and reduce noise. Reduce time and space required in data mining, allows visualization. Then that dimension reduction techniques. So here mapping data to a new space, the previous two spines. And then what is wavelet transform? Depose a signal into different frequency substance. So here we are dealing with frequencies and signals. And then the principle of computant analysis. Find the projection that captures the largest amount of variation in the data. The original data are projected onto a much smaller space, resulting into dimension reduction. We're still talking about dimension reduction. Find the engine vectors of the covariance matrix, and these. And so here we are going to do some equations. So still another equation. So data reduction 2, and here we have nearest reduction. Reduce data volume by choosing alternative smaller forms of data representation. Assume data fits in some model, estimate the model parameters, store only the parameters, and discard the data. So here we are reducing data using that method. So in here we have linear regression, multiple regression, and non-linear regression. In linear regression, data molded to fit the straight line. And multiple regression allows to response variation Y to be molded as the linear function of the multi-dimension future vector. So histogram of the analysis, clustering. So what do we mean by clustering? Portion of data set into clusters based on similarity and store a cluster representation. Can be very effective if data is clustered, but not if data is similar. Can have hierarchical clustering and be stored in multi-dimension index tree structures. There are many choices of clustering definition and clustering algorithms. One of the clustering, we have sampling. Types of sampling. Sampling obtains a simple sample to represent a whole set. And types of sampling have simple random sampling, sampling without replacement, sampling replacement, and stratified sampling. What do we mean by simple random sampling? There's an equal probability. What about simple sampling without replacement? An object is selected and is no longer is not removed from the population, is removed from the population. The next is stratified sampling, portion of the data set and draws samples from each sampling. So this will give you sampling without replacement. Raw data and satisfied sampling. So, and then we go to what we call the data cube aggregation, the lowest level of data cubes, based cuboid. The aggregated data of one individual entity of interest. A customer is a phone calling that a data warehouse. Multiple levels of aggregation in data cubes. Further reduce the size of the data to level in. Data reduction. We have a string compression, video audio compression, time sequence is not audio. So this is original data, compressed data, original data, approximately. So it reduces from the big thing to a small thing. And then we go to the data transformation and data discretization. Data transformation, a function that maps the entire set of values of a given attribute to a new set of replacement values. Each value can be identified with one of the new methods. We have smoothing, attribute aggregation, normalization, discretization. So here we have some formulas of normalization. So even in discretization, we have types. We have three types of attributes. We have the nominal, ordinal, and numeric. So those are the types of attributes in discretization. And then data discrimination methods have binning, histogram analysis, clustering analysis, decision tree analysis, and correlation. And then we have some graphs here. And then we have the concept hierarchy generalization. Organizes concepts, for example, attitude and values, in a hierarchical manner and usually associated with this dimension in a data warehouse. Concept hierarchy facilitates drilling and rolling in data warehouses to view data in multiple nudity. Reduce the data by collecting and replacing low-level concepts. Concept hierarchies can be explicit, specified by domain experts, data warehouse designers, so like database designers. So here we have an example, and thank you so much. That was group 2. Group 2 presenters were Mugera Isma, Bwire Conrad, and Nasaz Jovia.